So the lab we just did is a foundational lab. If you study physics in the future, you're definitely going to do this lab again. And it is the lab that helps us understand the connections between resistance, voltage, and current in a circuit. And there are a lot of great videos about this, and I'll attach them to this post, just little clips. But I'm going to give you the short, sweet, to the point, what you need to know. And if you want to take notes, this is on page 23 of your note packet. So we measured the current running through a circuit and the voltage across the resistor in that circuit. So the voltage we can think of as the energy in the circuit provided by the battery or the energy used by the resistor. And that's really what we measured, the energy used by the resistor and against energy per unit charge. So it's slightly different than energy, but we also measured the current, which is like the flow of charge, the rate of flow. And when we graph that, we end up with, for two of our values, if we graph voltage versus current, we actually change the voltages, we'll see that our points, our data, should line up generally in a linear fashion that goes through the origin 0, 0. And that shows us that there's a direct relationship. As voltage increases, current increases. And the thing that determines that relationship, if we look at our slopes of our equations, like we might have a slope that says y equals 10.2x, or an equation that says y equals 10.2x, the slope there is 10.2. And that might be for a 10 ohm resistor. So ultimately, this value of the slope of a voltage versus current graph, which is in volts per amp, is going to be a new thing that we're going to call the ohm. And this is resistance. So we can derive an equation from this experiment that says what's on our y-axis is directly related to what's on our x-axis, the current, and it's related by this thing that we're going to call the resistance of what we measured the voltage across. So resistance is a new property in a circuit, and essentially it's just like friction. It slows down the current. It doesn't stop the current necessarily, it just kind of slows it down. And it's the opposite of conductance, and we talked a lot about conductors. So just a key idea here is resistance is a property of a circuit. And so that means, or of the materials that you're measuring. So that means you can't change resistance unless you change the materials that you're working with. So we're going to use this equation a lot. It's like the F equals ma of electricity. And some people find that they like to do the triangle chart to like rearrange it. So we've got V on top, R, and I on the side. So a couple example problems here. Question 1 says, what is the voltage used by an electrical appliance that draws 0.4 amps of current and has a resistance of 3 ohms? So we're given the current, we're given the resistance, and we're looking for the voltage. So voltage equals current times resistance. So we'll just take that 0.4 amps, multiply it by 3 ohms, which you can use the omega symbol or you can spell out ohm, and that's 1.2 volts. A light bulb uses 240 volts of electricity, the current of 2 amps. What is its resistance? So really that comes from the slope of this graph, R equals V over I, or you can rearrange Ohm's law. So we're looking for the resistance. It's equal to the voltage divided by the current. So we'll take 240 volts and divide it by 2 amps. You get 120 volts per amp, or ohms. Both are good units. Then lastly, we've got a television which runs on 240 volts and has a resistance of 600 ohms. What is the current? So looking at this equation or our triangle, it's voltage over resistance. So we get 240 volts over 600 ohms. I think that's 0.4. Feel free to let me know if I'm wrong. So we're also going to analyze circuits that involve more than just one resistor. And this chart type template is going to be helpful for us. So we're going to call it a VIR chart, V-I-R. And the way this works is you're just going to use Ohm's law for each row. So give that a shot, and we'll have some time to practice on another day, probably Wednesday. You're in my class this year. So Ohm's law, short, sweet, and to the point. If you want to see more visuals, take a look at the links that I posted. Bye.